Hello to everyone. We are going to present electrodynamics pure substances. We are Paul Alberto, José Fernando, Carlos Esteban, Braulio Zulci, y Jonathan Esquivel. Next. The characteristics of the pure substances are the pure substances are formed by a single type of substance. They have a fixed or definite composition into different physical states of matter, like liquid, solid, and gaseous. They have present characteristics properties such as boiling temperature, specific and constant, or density. The pure substances are made of atoms or molecules all the same. They have specific properties that characterize them and cannot be separated into other substances by physical procedures. Pure substances are classified into elements and compounds. Next.
Okay, so as my partner was saying, the matter can be separated and categorized in pure substance and mixtures. The pure systems are elements, the elements that are found in the periodic table. And in compounds, which are two or more elements together. And the mixtures, which can be homogeneous. In these ones, we can distinguish between the components of the mixture. Otherwise, in the heterogeneous mixtures, we can clearly distinguish between the components of the mixture.
And the pure substance is divided in three parts: chemical elements and compounds and crystals. And the chemical elements, um, and tin and sulfur and diamond. The compounds is a sugar, a water, and baking soda. And the crystal is a salt, the protein crystals, a copper sulfate crystal. Next.
Okay, the changes of phase. The changes of phase are the changes that can suffer the matter from one state to another. The matter has four states, which are gas, solid, liquid, and plasma. The first three are more common than the others. And the changes of phase are the next ones. When comes from solid to gas, it's called sublimation. When comes from gas to solid, it's called depositation. When the solid turns to liquid, it's called melting. When the liquid turns into solid, it's called freezing. When the gas turns into liquid, it's called condensation. When the liquid turns to gas, it's called vaporization. When the gas turns to plasma, it's called ionization, and the plasma to gas, it's called recombination. These are the changes of phase.
The volume, there and two main phases that a substance can have, and solid and liquid and gas. The volume is empty space and something that is sufficient to hold on more things. And the volume is a system in an important extensive parameter to describe is a thermodynamics state. The specific volume is extensive property. It's the volume in the system in a mass. Next.
Pressure. The pressure is a magnitude that is defined as the derivative of the force with respect to the area. When the applied force is normal and uniformly divided over a surface, the pressure magnitude is obtained by dividing the applied force over the corresponding area. The formula is P is equal to F over A, and where the P is the pressure in Pascal, F is the force in newtons, and A is the area in square meters. In this example, a solid can be compressed. A liquid also can be compressed, only just a little, but no more. A gaseous can be compressed. And next.
Here we have the Pascal formula for pressure. This is used to calculate the pressure that is that something puts onto another thing. The formula is the next one. Force 2 is equal to F to force 1 multiplied by A2 divided over A1. This is how we calculate the pressure. Another formula that is equal is P is equal to F1 divided in I1, which is equal to F2 divided over A2.
I'm going to talk about the PT diagram of thermodynamics. I'm start down. PT diagram in thermodynamics is the most common ways to show the phase of a substance. A PT diagram can be constructed for any pressure substance. The line that separates the solids and the vapor phases is called the sublimation line. The lines that separate the solids and liquid phase, it's called the fusion line. And the line that separates the liquid and vapor phase is called vaporization lines. Next. So, in any substance that has a fixed chemical composition in each phase, be it water, nitrogen, helium, etc., it can be mixture, it has a homogeneous composition and a variable chemical composition. In a mixture of a two-phase of a pure substance, it is still considered a pure substance as long as it has a homogeneous chemical composition. So, which means that the mixture of air to pass is not homogeneous. I will talk about it quickly before talking about the main ones of the properties are have 5 phases. The first phase is the saturation temperature or saturation pressure. The simplest way to understand the concepts is a thought an example. We have always know that water boils or begins to evaporate at 100 degrees centigrados, but it does so at 100 degrees Celsius, but it does so at that temperature because the pressure at which it's found, it's an atmospheric pressure, which is a 1 atmospheric. The second phase is saturated steam plus saturated liquid. It is a state where within a system we have liquid at the same time as we have same steam. Quality, as we said, it's the amount of mass of vapor present relative to the amount of total mass without a control to balloon. There are there are equations to find the quality of a pure substance. Latent heat, heat required for the phase change to occur. And the last phases is a critical point, liquids plus vapor in equilibrium with its maximum pressure and temperature values. And now in the last pure substance properties have a three properties: compressed liquid or subcooling liquid. In a pure substance, it means that it is a liquid state, and that is a note about the evaporates, but lacks an additions of heat or negative change in pressure to the solve. Saturated liquid. The saturated liquid is a one that's about the to evaporate. It is a small important to note that when a pure substance is a saturated liquid, it is a totality in a that state as a liquid. No vapor signs it is about to begin to be created for saturated liquid water. And the last property of substance, it's a saturated stream or dry saturated steam. This is a vapor that is about to condense. In its phase, the substance is all vapor and it is necessary to remove heat or increase to the pressure to cause drops or liquids to be generated. And that's all.
And that's all for your team. And thank you for your attention.